Next problem, so let's find the derivative of this y here, which is equal to the product. So here, since it is a product, so we will need to use the product rule for differentiation. So how do we find again the derivative of a product, since it is sum of the two terms, and we can get the terms by just taking the derivative of one factor at time. So we can get here this first term times the derivative of the second term plus the second term times the derivative of the first term. And how do we take the derivative of this? When it is like a function raised to a power you raised to n, so to find its derivative we bring down the power and then subtract 1 from the power times the derivative of the base, the derivative of u with respect to x, and then this one here we apply the same rule. We bring down the powers, that is 4, subtract 1 from the power, it is becomes 3 times the derivative of the base, which is x cubed. Now there are just polynomials. It is very easy to complete for the derivatives. So the derivative of 5x squared is 10x and the derivative of 3 is 0, so that will be 10x, and the derivative of x cubed is 3x squared plus the derivative of 2x squared is 4x, and then minus derivative of 1, which is equal 0, and we may write our answer this way. So we just multiply this 6 and 10x, we will get here 60 x, and this 4 here we can multiply it to the factor, we will get 12x squared plus multiply, we will get 12x squared plus 16. Find the derivative of this function y, example 2 raised since of x squared plus tangent of y raised to x cubed. Since it is a sum, we know already that the derivative of a sum equal to sum of the derivative, so we just have to find the derivative of each terms. So here, what formula do we need? Since this in the form of constant raised to a function, we need the formula for raised to u, and then this is the tangent of a function. We need a formula for derivative of tangent. So if we use these formulas, we will get here the derivative of a to the u is to u. Just copy the function times ln at times the of u the power with respect to x, and then the above tangent u is the second square u times the derivative of u with respect to x, and we still have here the derivative. Let's complete for this derivative. Now we want to find the derivative of sine of a function of x, so we need to use the derivative of sine u, and the derivative of sine u is a cosine times the derivative of u with respect to x, but the derivative of this x squared with respect to x is equal to 2x. Now this we need the formula for the derivative of e raised to a function y raised to u, and we have the formula which is e to be the u times the derivative of u with respect to x, which is equal to 3x squared. So if we are going to write our final answer 2 times ln 2 is just ln 2 squared, which is equal to ln 4, and we just copy this factor here, and then we have here the x, and then times cosine of x squared, and then here this is just 3x squared times e raised to x cubed times second square of y raised to x cube times raised to x cube. Moving to our problem, let's find the derivative of this with respect to t. So our variable here t is this of power of second of function. We do not have a formula for power of second, but we have a formula for power of function, so that is the power rule, which is the chain rule. So we need to use that rule to find the derivative of this one. So here we think of this function as a function raised to a power. Okay, so we need to use the formula for derivative of u raised to n, and the derivative is bring down the power, subtract 1 from the power times the derivative of the base with respect to t. In this case, now what is the form of our function? This is in the form of a function. So this is second u, so we have a formula for derivative of second u, so we use this formula. It is equal to the second u times tangent u times the derivative of u with respect to t. Now we are left this one, and what is the form of our function? It is cosine of a function, so cosine, so you use the derivative of cosine u, which is negative sine u times the derivative of u with respect to t, and finally we get the derivative of sine t with respect t, which is equal to cosine t. Now we can write our answer. So this is a negative times 2. You will get here negative 2, and then you have 2 copies of this one here. So you can write this down, a second square of cosine of sine t, and then you have times this expression, and then times since sine t, and then times cosine. Let's find the derivative of this y, which is equal this differentiate raised to 5. So it is clear that we have to use the power rule with the chain rule. So when we take the derivative of the both side with respect to x, we bring down the power, subtract 1 from the power times the derivative of the base with respect to x, and now we have a derivative of difference. So this is the equal difference of derivative. So the derivative of sine x is cosine x, and then minus. So this is a power of conjugate root x square, root of x. So the derivative of this, we have to use again the power rule with the chain rule. So we bring down the power to and then subtract 1 from the power. It becomes conjugate square root of x times the derivative of your base. Your base here is conjugate square of x, so the derivative of conjugate square of x with respect to x. Now what is the form of this function? It is conjugate of function, so we need to use the derivative of conjugate u with respect to x, and the derivative is equal to negative square u times the derivative of u with respect to x. Now we have written the square root of x in terms of rational exponents, so we write it x raised to 1/2, so that we can easily apply the ordinary power rule. So the derivative of this is you bring down the power 1/2 and subtract 1 from the power, so that will be negative 1/2. So we are done with the complete these derivatives. We can now write our final answer as this expression: 5 times this raised to 4 times the quantity. So you have here cosine x, and then negative 2 times negative times 1/2. So that will give you a positive 1. So that will be of square root of x times square for square root of x all over. So this one you can write it down as square root of x. Now let's find the derivative of this y, which is equal to 5 raised to 4 raised to x squared. So since this is a constant raised to function, we need the formula for derivative of raised to u, and the derivative of raised to u is just copy the function times ln of the base times the derivative of the exponent, which is the exponent which is 4 raised to x squared. And again here we apply that rule to compute for the derivative of this constant raised to a function. So again you copy the function and then times length of the base times the derivative of the power, which is equal to x squared. So this derivative of that is equal to 2x. So therefore the answer here will be, so you have here ln 5 times ln 4 times 2 becomes 2. Ln 4 is the same thing as a ln of 4 squared, so one can write that down as the ln of 16 and then times x and then times this expression times 4 raised to x squared. Moving our next problem, so let's find the derivative of y, which is equal to sine inverse of ln of constant x. So what is the form of our function? It is sine inverse of function. Since inverse u, but we already have formula for the derivative of sine inverse u, and that is 1 over the square root of 1 minus u squared times the derivative of u which respect to x. Now what is the form of this ln of a function? And we already have a different formula for derivative of ln u, and we that one that is 1 over u times the derivative of u with respect to x. And finally, using an ordinary formula, derivative of constant x is negative contingent x on, we can write our answer to this there times 1 over x. We cancel the constant x, so right left with negative x of this denominator. Let's find the derivative of y, which is a function of log base 4 of tangent inverse x. So again, applying chain rule, it is very important to understand the chain rule completely. So here we take first the derivative of the outer function evaluated at this 1 times the derivative of the inner function. So derivative of log base 4 of tangent inverse x. So since we already have a formula for derivative of log of a function, okay, at any base, so we use that formula. So it will be a 1 over ln our 4 is 4 and then times u, okay, tangent inverse x times the derivative of u with respect to x. And we also have a formula for derivative for tangent inverse to x, which is equal to 1 over 1 plus x squared. So therefore can write our answer and depends on f prime. So this expression times 1, so it is equal to the expression divided by ln 4 times 1 plus x squared times tangent inverse of x. Moving to the last problem, so let's find the derivative of this function. So you may use here derivative of a quotient because we already have a formula for derivative of quotient, but I think it is better if we write this down as a power of f of x minus g of the to the x. So we move this to the numerator and we can write it down, and this expression raised to negative 1 over 3. So it is a power of a function. In that case we can use the power rule with the chain rule. So we complete for when we complete the derivative, we bring down the power, subtract 1 from the part, so that is a negative 1 of 3 minus 1 is the negative 4 over 3 times the derivative of the base with respect to x, and the derivative of a difference is equal to difference of derivative. So this will be prime f prime of x minus, again you apply here chain rule because g is the function of a function. So first take the derivative of g evaluated at e to the x times the derivative of the inner function with respect to x, so that is again chain rule, but the derivative of e to the x with respect to x is e to the x, so therefore our final answer is this expression times negative 1. So you will get negative f prime of x plus you have here e to the x times g prime of e to the x, and all over you have here the 3 times this one, but you move this to the denominator, so you change the power, it becomes positive 4 of 3. That is for this lesson. I hope that you can now easily find the derivative of any function. If you enjoyed to these tips that you learn here, please don't forget to hit that like button below and share.